In this video, we're going to look at solving equations with algebraic fractions in that reduce to quadratics. Let's start off with a question. We're asked to solve each of the following equations. So the first one, we have an algebraic fraction of x over x plus 4, plus another algebraic fraction, which is 1 over x, and that's equal to a numeric fraction of 3 over 4. In our video on adding and subtracting algebraic fractions, we looked at adding by finding a common denominator. The common denominator of these two fractions now will be the multiple, or if you like, the product of x and x plus 4. We can combine this as a single fraction, or initially we can just write it as two single fractions and add them together. I prefer to write it as one single fraction, but I'm going to do it both ways to start off with. So if we look now, the common denominator is going to be the product of x multiplied by x plus 4. If you're unsure about that, if you think of a numeric set of fractions, if we have now 1 half plus 2/3, we know that the lowest common multiple will be the product of these two, which is going to be 6. So that's going to give us our common denominator. One way we could look at this now is I'm going to combine this into a fraction with the common denominator. If I do that, I'm going to multiply the denominator by x, therefore I need to multiply the numerator by x. Whatever we do to the top of a fraction, we must do to the bottom. If I now consider this one, I need to multiply the denominator by the x plus 4 to get my common denominator. So I'll have x, then I'll have x plus 4, and I also need to multiply the numerator by my x plus 4. So we're going to end up on this one now with one lot of x plus 4. That is going to be equal to 3 over 4. If we think what we've got now, we have this common denominator. So for example now, if I had, let's say I had 1/7 plus 2/7, I could simply write this now as 1 plus 2 over 7 or 3/7. Therefore what I can do, just expanding the brackets, we can say that x squared plus, then I'm going to have one lot of x and one lot of 4, plus now x plus 4 all over the common denominator of x, then we're going to have x plus 4 will be equal to 3/4. At this stage now, I'm going to multiply both sides of the equation by x multiplied by x plus 4 and both sides of the equation by 4. Sometimes people say cross multiplying, technically the same thing. I prefer to say we're going to be multiplying both sides of the equation by this denominator and this denominator. If I do that on the left hand side, we're going to have 4 lots of x squared plus x plus 4, and that will now be equal to 3 lots of x multiplied by x plus 4. So I've cleared the fractions by multiplying. I'm now going to expand this out, so we're going to have 4x squared plus 4x plus 16, and expanding on the right hand side we're going to have 3x squared plus 12x. I want a quadratic equation in the form ax squared plus bx plus c is equal to 0, and I can look to solve. So I'm going to subtract the 3x squared from both sides and the 12x from both sides. So 4x squared minus 3x squared is 1x squared. If I subtract now the 12x, that's going to leave me now minus, and then we're going to have the 4x minus the 12x, which is minus 8x. Then we're going to have now plus the 16, and that will be equal to 0. This looks like it's going to factor quite nicely. We need two numbers that multiply to give positive 16 and add to give negative 8. That's going to be x minus 4, and then we'll have x minus 4, or if you like, x minus 4 squared. That will be equal to 0, so we can see that we'll have one repeated solution of x is equal to 4. If we wanted to go ahead and check that, let's go ahead and check that works. If we put it in here, this would give us now, with x being equal to 4, we would have now 4 in the numerator. In the denominator we'd have 8 plus 1 over 4. Does that equal 3/4? Well, if we look at this now, we could write this as 2 over 8. So 4 over 8 plus 2 over 8 gives us 6 over 8, which of course gives us 3/4. So we can see that that works. I think it's important to stress at this point, in this particular equation, if you worked x out to be either -4 or 0, those would not be valid. Division by 0 is undefined, so do check your solutions. Often students do some good algebra and then find out that they don't have valid solutions. So that way what I did was looked at two single fractions. What I'm now going to do is look at one complete fraction with the common denominator. So instead, what I could have done is just said, well, I know that my common denominator is going to be the x multiplied by x plus 4. And I say to myself, what do I need to multiply this by? Well, it's the x, so we can write this now as x multiplied by the x. What do I need to multiply this one by? Well, it's the x plus 4. So we're going to have plus one lot of x plus 4. And that would be equal to 3/4. So this way I think is a slicker way. All you've done is just gone straight to this point right here. I appreciate some people don't like this method initially, but generally it's a lot more straightforward. So if we look at this, we're going to have x squared plus x plus 4 over now the x, and then we're going to have the x plus 4, and that would be equal to 3/4. So at that stage we would simply go ahead and pick up this part right here. So you can either do it with a common denominator, or you can consider two fractions. I just understand how people prefer to do this by saying, what do I need to multiply this one by, and what do I need to multiply that one by. Okay, let's have a go at another one. Let's try this one right here. So we've got x over x minus 2 minus x over x plus 2 is equal to 4/3. So what I'm going to do is simply write the common denominator. The common denominator will be the product of x minus 2 and x plus 2. Just be careful on this one. This could be now the difference of squares. So we could have x minus 2 multiplied by x plus 2, which would give us x squared minus 4. So if you have a question like that, you might want to split it up. It's entirely up to you. So we've got now x minus 2 multiplied by x plus 2. So if I consider now, what did I need to multiply this fraction by? Well, it's this denominator. So that would just give me now x multiplied by x plus 2. And we need to be very careful here. We've got a negative sign. So when I come to expand this, we just have to be a bit careful. So what did I need to multiply this fraction by? The answer is the x minus 2. So the x minus 2, and that would be equal to 4/3. So let's go ahead and expand the numerator. X times x is x squared. Then we're going to have plus 2x. I need to be very careful here, minus x squared. Then I've got the two negatives, so that's going to give me a positive, and that will be plus 2x. And that now is going to be over x. And if you want, you can write this, and I'll just write here as x squared minus 4. Difference of squares, and that's equal to 4/3. Okay, let's tidy that up. So you might still have this as x minus 2x plus 2. Perfectly fine. These x squares are going to cancel. 2x and 2x is going to be 4x. And that is going to be over x squared minus 4. And that will be equal to 4/3. At this stage, if you wanted, and I'm not suggesting you should, and I'll do it over here, what we could do at this stage is divide both sides of the equation by 4. If I did that, it might make my algebra slightly easy. You don't have to, but it might do. So that's what we would end up with. But I'll assume that we didn't spot that, and that's perfectly fine. So at this stage, what we're going to do is now multiply both sides of the equation by x squared minus 4, or if you like, x minus 2, x plus 2, and both sides of the equation by 3. So that's going to give me 3 lots of 4x, and that's going to be equal to 4 lots of x squared minus 4, or if you've still got your x plus 2, x minus 2. Now, when you're thinking about this, you're saying to yourself, well, I don't really understand what's going on here. Now, if we looked at this numerically, let's say we had 5/6 was equal to, let's say now 7x over, and we'll go on here, let's put 7x over 13. Okay, if we think about this now, if I multiply both sides of the equation by 6 and both sides by 13, just consider what's going to happen here. We're going to have 13 times by 6 times by 5 over 6, and that's going to be equal to 13, and we'll put it just here, 13 times by 6 times by 7x over 13. So what we can see over here, these 6's are going to cancel and these 13's are going to cancel, which just leaves us now the 13 times by the 5 is equal to the 6 multiplied by the 7x. So if you're unsure why these denominators are disappearing, hopefully that makes sense. If it's confused you even more, I apologise for that, but hopefully it should be logical of where those denominators are going to. Okay, so let's go ahead now and solve this. We need to expand the brackets. So if we do that, this is going to give me on the left hand side, we've got 12x, and that's going to be equal now to 4x squared minus 16. Quadratic equation in the form ax squared plus bx plus c is equal to 0. So 0 will be equal to 4x squared minus the 12x minus the 16. At this point you could try and factor it, or alternatively you might say, well, I can divide the whole thing by 4 and make your life significantly easier, and that would give us this scenario. That looks like it's going to factor nicely. We're going to have x and then we'll have minus 4 and we'll have x plus 1, and that will be equal to 0. So nice straightforward bit of quadratic factoring. So from the factors, either x minus 4 is equal to 0, which gives us x is equal to 4, or x plus 1 is equal to 0, and x is equal to negative 1. If these steps don't mean anything to you, please go back and check, as this video is building on lots of different topics that we looked at. Now with this one, we would multiply both sides by 3, and we multiply both sides by x squared minus 4. And that would give us now 3 lots of x is equal to 1 lot of x squared minus 4. Or you could have still had 3x is equal to 1 lot of x plus 2 multiplied by x minus 2. It's entirely up to you. As you can see, there's a fair bit of flexibility. So we've got 4 and negative 1. We could go ahead and check those in our answers. Certainly we can't have plus or minus 2, as division by 0 is not allowed, and I will let you check those to see if they're okay. Okay, let's have a go at another one, this one right here. So on the left hand side, I'm going to have the common denominator. The common denominator is going to be x plus 1 multiplied by x plus 3. So with this one, I need to multiply the 2x, so we'll have 2x multiplied now by the x plus 3, and then with this one, we've got a negative again, and I'm going to have the x multiplied by the x plus 1. That is going to be equal to 25 over 24. So let's now tidy the numerator. We're going to have, and being careful with this one, 2x squared plus 6x minus x squared minus x. So minus x squared minus x. And that, I'm not going to expand the denominator, is x plus 1, and then we can have x plus 3. That will be equal to 25 over 24. Okay, so let's now just do a bit more tidying in the numerator. We can see we've got 2x squared minus x squared. Well, that's going to give me 1 lot of x squared. 6x minus x is going to give us plus 5x. And that is over x plus 1 multiplied now by x plus 3. So let's go ahead. That's 25 over 24. So multiplying both sides of the equation by 24 and both sides of the equation by this denominator of x plus 1, x plus 3, we'll have 24 lots of x squared plus 5x will be equal to 25 lots of x plus 1, and then we're going to have x plus 3. So let's go ahead and multiply this out. We can see that's given us 24x squared plus, and then we're going to have 120x, so 120x. That's going to be equal to 25 lots now. If I expand these brackets, x squared plus 3x plus 1x, which is going to be plus 4x plus 3. So let's write this out. So we're going to have now 24x squared plus 120x will be equal to 25x squared plus 100x plus 75. So if we now set the left hand side equal to 0, we always want a quadratic of this form now, in the form ax squared plus bx plus c is equal to 0. Once we have that, we can look at a method, whether that's factoring, completing the square, or using the equation. Okay, so subtracting the 24x squared off both sides, that's nice, that leaves me x squared. Subtracting 120x, that's going to leave me now on there, we're going to have minus 20x plus 75. That looks like it's going to factor 5 and 15, so x minus 5, and then we'll have x minus 15, that x minus 15 rather than 17, and that looks good. Negative 20, 75, 5 times 15, 75, so we can say, solving the quadratic, x is equal to 5, or we've got x is equal to 15. Again, check back in the equation those are valid, but they look pretty good. So there we go, nice and logical, nice and straightforward. Okay, let's try some different ones. Let's try something that looks a bit. Let's try this one right here. Okay, so number 6. So common denominator on this one is going to be the product now of 2x plus 1 multiplied now by 2x plus 7. So single fraction. I'm going to have now x multiplied by the 2x plus 7. I'm then going to subtract from that now the x multiplied by the 2x plus 1, and that is going to be equal to 2 over 15. So if we look at expanding the numerator, x times by 2x is 2x squared, plus 7x. We need to be careful here, we're going to have minus 2x squared minus 1 lot of x, and that is going to be over the common denominator of 2x plus 1 multiplied by 2x plus 7. That will be equal to 2 over 15. So tied in the numerators, we're going to have a numerator on here is going to be 6x, the 2x squares are going to cancel, over now the common denominator of 2x plus 1 multiplied by 2x plus 7, and that is going to be equal to 2 over 15. At this stage, if you wanted, you certainly don't have to, you could divide both sides of the equation by 2. If I did that, we would end up now with 3x over 2x plus 1, so 2x plus 1 multiplied by 2x plus 7, and that is going to be equal to 1 over 15. I'm not suggesting for one moment that that's made a massive improvement. Often though, if you can cancel common numeric factors, then go ahead and do it. So multiplying both sides now by the 2x plus 1 and then the 2x plus 7, and both sides by the 15, we're going to have 15 lots of 3x will be equal to 1 lot now, which has made it marginally easier, 2x plus 1, and then we've got 2x plus 7. So if we look at this on the left hand side, 45x, so let's write this out, 45x, and then on the right hand side, 4x squared, so that's going to be equal to 4x squared, plus 14x plus 2x, which is going to give me plus 16x, and then we're going to have plus 7, and that now will be equal to the 45x. So at this stage we simply need to subtract the 45x from both sides, and we have a quadratic equation in x. 4x squared, we're going to have now from here negative, so we're going to have minus 29x plus 7. Can we factor that? I think we can. 4 times by 7 is 28, so yes, we can factor that. We're going to have 4x minus 1, and then we're going to have x minus 7. That looks pretty good. If you're unsure on factoring to when the coefficient of the term in x squared is not 1, do check out the site, as there's plenty of stuff on there. So 4x minus 1 is equal to 0, then x is equal to positive 1/4. If x minus 7 is equal to 0, then x would be equal to 7. So 2 possible solutions, and we would go ahead and check those and check that they work in the equation. So if we look at that now, we've got on here, on there, positive 1/4, and then we've got 7. If you wanted to do it with, for example, now, let's just go ahead and do that. Let's put it in a calculator. So let's say we got 1/4, so 0.25 is 1/4. So if we look at this one, what I'm going to have now is the answer, and I'm just going to sub this in, over 2 lots of the answer plus 1. And then we're going to subtract from that now the answer, and then we're going to divide now by 2 lots of the answer, and then we're going to add 7. So that should now give me 2/15, which it does. So that was using one solution where we had 1/4. And then if you use the other solution where x was equal to 7, so I could put 7 in. You certainly don't have to do it, you could do this in your head. Let's just put that in. So if we do that now, we're going to have the answer. So that's the answer over 2 lots of the answer plus 1. And then we're going to subtract from that now the answer. So I'm testing my 2 answers, and then we've got 2 lots of the answer plus 7, and that gives me 215. So we can see that those are nice answers. Okay, let's just do 1 or 2 more. Let's see if we can get anything that's not going to be as nice as that in terms of the solving it. Okay, I think one of these is going to be a bit more interesting. So let's do this one. 1 over 2x plus 3 plus 1 over 6 minus x is equal to 2/5. So let's get the common denominator now, and the common denominator is going to be 2x plus 3, and then we're going to have on this one now 6 minus x. And then if we consider what we're going to have, we're going to have 1 lot of the 6 minus x, and we're going to have plus 1 lot of the 2x plus 3. So I'm simply combining the fractions, as hopefully now you're comfortable with. That's equal to 2/5. So if we look in the numerator now, 1 times by 6, so we've got 6 minus x plus the 2x plus the 3, over now the denominator of the product of 2x plus 3 and then 6 minus x, and that is equal to 2/5. So what do we have now in the numerator? We've got 9 plus x, or we could say that is x plus 9. So x plus 9 over 2x plus 3 multiplied by 6 minus x is going to be equal to 2/5. Multiplying both sides of the equation by 2x plus 3 multiplied by 6 minus x and both sides by 5, that's going to give us 5 lots of x plus 9, and that will be equal to 2 lots now of this 2x plus 3 multiplied by 6 minus x. So on the left hand side, 5x plus 45, just expanding the brackets, and then we're going to have 2 lots of 12x minus 3x, which is going to give me on here, so 12x minus 3x is going to give me 9x. We're going to have minus 2x squared, and then we're going to have plus 18, and we can go ahead and expand that out. So we've got 5x plus 45 is equal to 18x minus 4x squared plus 36. I'm going to add now 4x squared to both sides, so 4x squared. Then I'm going to subtract the 18x, which is going to give me minus 13x, and then we're going to subtract now 36, which is going to give me plus 9, and that will be equal to 0. Looking at that, I think we could go ahead and factor it. Let's just check. 4 times by 9, positive 9 is 36, so yes, we can factor this. So let's go ahead and factor that one. What are we going to have? 4x minus 9 multiplied by, and what's that going to give me? X minus 1, and that will be equal to 0. Let's just check. 4x squared minus 4x minus 9x plus 9. Again, if you want some help with that factoring, do check out the site. So if 4x minus 9 is equal to 0, we can say that x is going to be equal to 9 over 4. If you're not happy with that step, if you think 4x minus 9 is 0, 4x is equal to 9, x is equal to 9 over 4, or we've got that x will be equal to 1. So that's what we end up with, and of course we could go ahead and check those if we wanted. So let's just, I'll do 1 just to check that 1 is valid. So that's going to be 1 over, now if x is 1, that's going to give me 5. And then we're going to have this one, which is going to be 1 over 6 minus 1, which is 5. 1/5 plus 1/5 is 2/5, and I will let you check the other answer. Okay, I'm hoping one of these is going to give us a nasty bit of work to do in terms of the solution. So let's try this one here. Seeing this is the last one, I'm hoping that it's got a bit of bite in it. X plus 1 multiplied by x minus 6 will be our common denominator, and that now is going to be over 3 lots of the x minus 6 plus now 7 lots of the x plus 1, and that will be equal to 5. If you like, this is just 5 over 1. Okay, so let's have a look at what we're going to get now. In the numerator, we're going to get 3x minus 18 plus 7x plus 7, and we're going to divide that now by the x plus 1 multiplied now by the x minus 6, and that is going to be equal to 5. So tied in the numerator, we've got now, what's that going to give me? 10x minus 12, let's check that. So what is it, 10x minus 11? Let's write this in. So 10x minus 11 over now this quantity right here, which is x plus 1, and then we've got x minus 6 is going to be equal to 5. So multiplying both sides by 1 and both sides by the x plus 1, x minus 6, we've got now 10x minus 11 is going to be equal to now to the quantity 5 lots of x plus 1 multiplied by the x minus 6. Hopefully you can appreciate that that is just doing the same as that because we've just got an integer value. So we've got 10x minus 1 is equal to 5 lots of x squared minus 6x plus 1x, which is minus 5x, and then we can have minus 6. So we've got now 10x minus 1 is equal to 5x squared minus 25x minus 30. So quadratic equation, left hand side to 0, 5x squared, subtracting 10x from both sides, minus 35x, and then we're going to have now minus 29 is going to be equal to 0. Okay, is that going to factor? No, the answer is no, it's not going to factor. So what I'm going to do is use the quadratic equation. We know that for solutions, x will be equal to negative b, then we're going to have plus or minus the square root of b squared minus 4ac, all now over 2a. So with our quadratic, we've got a is equal to positive 5, we've got b is equal to negative 35, and we've got c is equal to negative 29. So I'm simply going to substitute this into a calculator. So with the calculator now, let's go ahead and do that. So we've got negative 35, so that's going to give me 35. We'll take the positive one first. Then we've got negative 35, which we need to square. You can, of course, just write 35 squared. Then minus now 4 times by a, which is 5, times by c, which is negative 29. And that's all over 2 lots of a, or 2 lots of 5 is 10. So if we do that, that gives us now this quantity right here, which is 7.75, correct to 2 decimal places. And of course the other one is just going to be, so it's just going to be the negative. So 35 plus 9, what's that, 19 root 5? 19 root 5 over 10. Let's just check that I've done that right. 19 root 5 over 10. So the other one is going to be now the minus. So 35, then we're going to have minus the 19 root 5 over 10. And generally speaking, at this level, you will be asked to give them to 2 or 3 significant figures or decimal places. So let's see if that works. Let's just, we can put this in as my answer, shift store A. So that's in as my answer. All I've done is hit shift store A. So for example, if I lost that, I can press recall A and it will be back. So let's put this in the original equation. What was the original equation? So if we do that, let's go ahead and do that. So we're going to have now 3 over now a, and I could use my answer, of course, a plus 1, and then we're going to have now plus, and then we're going to have 7 over our answer, which is going to be a minus 6. What does that give us? That gives us now 4.3 and so on and so forth. So somewhere along the line I must have done something incorrect. We're expecting it to give us 5. So let's establish where I've gone wrong. So my answer here, let's just bring it back, recall A, we've got 35 plus 19 root 5 over 10. And we saw when I put this in, 1 over the value of A plus 1, this should now give us the 5. So if we do this now and put this back in, we can see from here, let's just minus the 6, we end up now with this value which is incorrect. So let's work back and see where we've gone wrong. So we've got a common denominator, which is fine. Then we've combined these. I've multiplied out, which looks fine, 3x minus 18. So I've added, which is going to give us now 10x minus 11. I can now see at this stage, I'm going to have on here 5 lots of x squared. Then we're going to have minus 5x plus x minus 6. If we go ahead and expand it, we can see that my error has come just here. So if we do that and we go back, I need to make that 11. So you can see now how these slips make checking worth it in the end. So if we go back here and start again, this is now wrong. So if we do that, we've got 10x minus 11 is going to be equal to 5x squared minus the 25x minus 30. So a silly little slip by myself quite clearly has ended up in getting it wrong. So 5x squared, then we're going to now subtract the 10x, which gives me minus 35x, and then we're going to now add the 11, which is going to give me negative 19. So this now gives us the quadratic we should have. So let's go ahead and solve the correct one. Let's do that. So we'll take now a, so a is going to be equal to 5, b is going to be equal to negative 35, and c will be equal to negative 19. So through the quadratic equation, we've got now minus b. So that's going to be now negative 19, which we can just put in as, negative 35, so we can put that in as 35, plus now the square root of, and this is the same as putting 35 squared, minus 4 times by a, so we can write 4 times by 5, times by negative 19, and that will all be over now 2 lots of a, which is going to be 10, and that gives us 7.5, and so on and so forth. So let's see if that one works, and of course our other one is just when we switch this over and we have negative, so negative 5.506. So let's say now negative, and we'll put on here, so that's going to be negative 0.51, and that is correct to 2 decimal places. So if we go ahead and write that, and then if we wanted now the positive value, we're going to end up with that. Okay, we need to let's see if we can do that. That's just a bit of a screw up. Let's just not enjoying this one, am I? Let's do 35 plus the square root of 35 squared. Then we can have minus now 4 lots of a, which is going to be the 5, times by the c, which is negative 19, and this is all over 2a, so that's going to be 10, and that gives us the first one 7.51. So back where we were, so 7.51. So let's now just store this in the calculator. So shift store a. Let's see if this works. We'll go ahead and check this now, and we will do that one. So what have we got? We've got 3 over now a plus 1, so a plus 1, and then we're going to add that now to, let's go for 7 over the value of a, and we're going to subtract 6 from this, and it should give us 5. There we go, we got there in the end. So algebraic fractions, we're just looking at combining the fractions and then solving the equations. So if it's not coming up and it doesn't make sense, go back, check what you've done. As you can see here, I've missed out the 1 here, and it screwed it all up. We worked it out in the end and got there.